Hello, my name is Hans Heiser and this is
Anura&Hans.
For this lesson we are using a web-based interactive periodic table. This program is freely available at webelements.com. Using this tool, students can research the properties of each element in the periodic table. As well as the students will be able to recognize how the elements in the periodic table are organized. Educators will find this tool extremely useful way to engage student interest. The interactive features help them to swiftly understand the basics knowledge expected of high school chemistry students. It gives the physical and chemical properties of each element. Browsing these properties on the internet can further enhance student learning. In addition, it provides information on real-life uses of the elements. They can further explore the compounds that this element will make with other elements. They will also get the latest information available on each element. This tool has many applications, such as researching the history, uses, crystal structure, physics, thermochemistry, atoms, atom and ion sizes, and electronegativity, and many, many more. We will focus on electronegativity for the high school chemistry classes.
It is very important for high school students to understand how the elements are organized in the periodic table to better understand the subject chemistry. Now here we use an activity on electronegativity. Here we will identify the differences in electronegativity across the elements in the periodic table. For example, if you want to obtain electronegativity information, you first click on this electronegativity tab and then browse over the symbol and click on the symbol representing the element. Here, for example, you get information on electronegativity of fluorine element. You can see that it gives you a description of the electronegativity of fluorine and a table with electronegativity values calculated using different methods, and also it provides you a periodic table with colored representation of electronegativity values relative to fluorine. As we can see here, fluorine is the red color indicating the highest electronegativity value in the periodic table. And in addition, if you want to further compare the electronegativity of fluorine with other elements in the periodic table, you can click on one of the scales for electronegativity calculations. For example, here I am clicking on Pauling electronegativity. So if I scroll down, I get a periodic table image with elements represented by circles. Each circle represents the electronegativity value. So the radius of the circle indicates the extent of electronegativity for each element. As we can see, that radius increases across the periodic table from left to right along a period. At the same time, you can see that the radius of the circle decreases as we go down across down the group, so indicating decrease in electronegativity. Now, if you want to get information on a particular element, for example, I click here nitrogen. When you scroll over nitrogen element, it gives you the value of the electronegativity on Pauling scale in addition to the visual representation. As we go down, here I can see that value for nitrogen here it's 3.04. As we go down, for example, in the same group, the phosphorus value for electronegativity is 2.19. You can see that the difference in electronegativity between the two elements here. So, therefore, students will find this interactive periodic table very useful to collect information and to identify patterns within the periodic table. It's not only electronic configuration, but you can find periodicity in other properties of elements. For example, in ionization energy, binding energies, electrical resistivity, things like that. Thank you.
Thank you for listening to our presentation, and I hope you enjoyed it.